Okay, so this is your first ed puzzle. We're looking at trigonometry from the basic fundamental level and how it revolves about an equilateral triangle and a square and rectangles, or sorry, triangles created from those shapes. So we know that this is 60, and so is this because of the fact that it's equilateral. The sum of the interior angles is 180. So this shaded triangle, I can say this is 30, this is 60, and this is 90. Now, 30, 60, 90, we need to hurry up and memorize or remember that are special right triangles that have relations of the following. X root 3, and 2x. And then over here it's 45, 45, 90, which have x, and x root 2. Okay? This is 45, this is 45, and the other one is 90. Okay, so we're going to use these quite frequently through these notes and throughout this unit of how to solve for these particular lengths of the triangles. So when using Pythagorean Theorem, you usually start with something of a right triangle and find the other. So it's basically saying you're going to start with two sides and find the other side, the third side, if you will. Okay, this is with a right triangle. However, in special cases, and the way we do this is we do the two sides and we find the third side by the equation a squared plus b squared is equal to c squared. However, in special cases, and when I say special, I'm talking about these two special cases here, you can actually start with only one of them and we can find the other two. So we can say you will start with only one of a right, like one angle or one side, one side that is the angle is going to correspond to that. So one side, and then we can find the other two. So how does that work? Okay, so let's move on and I'll show you. This is a 30, 60, 90 degree triangle. So I will make my chart right here, 30, 60, 90. And the values that I'm given, they will correspond with, again, x root 3, and 2x. So the question is, opposite from 30, I'm given an 8 centimeter length. So underneath this 30 column, you're going to put 8, because that's a given, and this creates an equation of x is equal to 8. So if x is equal to 8, I can put it there, and I can put it there. So that the opposite side from 90 is 2 times 8. So that means opposite from 90 will be 16 centimeters. And then if I put 8, which is x, if I put it where x is at, I can say that the opposite from 60 angle, which is going to be down here as the letter B, will be 8 root 3. Okay, so if you're wondering how do I know that this is a special right triangle, I was given 30 degrees. This is 90. So the third triangle, or the third angle of the triangle, has to be something plus 30 to equal 90. So that's where it becomes the 30-60 triangle. So from there, I'm going to quickly fill in. This is 30. This is 30. And this is 45. This is 45. And the last is 45. All the reason because these will add up to 180. So if the 90 degree is taken care of, I know those other two have to equal 90. Because 90 plus 90 is 180. Okay, so quickly let's go ahead and do these now. So again, 30, 60, 90, x root 3, 2x, and the corresponding side that I'm given on this triangle is opposite from 90 is 10. So I'm going to put that in that 10 or in that 90 column. And then I'm going to make an equation out of this. 2x is equal to 10, and if I divide both sides by 2, I get x is equal to 5. So that means this x right here is going to be equal to 5, and this right here, when I substitute 5 in, is 5 root 3. So the opposite angle from 30, so again I'll draw that, that's going to be 5 inches. The opposite angle from 60, I'm going to draw that, is going to be 5 root 3 inches. Okay, so let me go ahead and put centimeters up here. Alright, so now I will do this next one. And again, 30, 60, 90, x root 3, 2x, and the side that's given on this one is opposite from 60. So opposite from 60, I'm going to put under the 60 column the 9 units. So this one's a little bit different. X root 3 is equal to 9. So if I divide by that, I'm going to get x is equal to 9 over root 3. Now you can put this in the website and get it correct. However, on tests and quizzes on paper, I want you to rationalize this. You'll rationalize by getting rid of the square root in the denominator by multiplying by a form of 1, which is root 3 over root 3. The denominator will then multiply out to become 3, and the top will remain 9 root 3. So that when I simplify, which we will do, it simplifies to 3 root 3, because you only simplify that coefficient part. So 3 root 3 is where x is at, which is the opposite from 30. So opposite from 30, this will be 3 root 3 units. And then since x is equal to 3 root 3, when I put it here as substitution and multiply by 2, I get 3 times 2 is 6 root 3. So opposite from 90 degrees, I will put 6 root 3 units. So now, real quick, I will do these examples. Again, they work just like the other column. 45, 45, 90. It will be x root 2. This is from memorization. And then I'm given the opposite from 45. So if this is 14, and that's x, I know that the next one's 14, and then the next one is 14 root 2. I've established x as 14. When I plug it in, I'm going to get 14. Plug it in, I'm going to get 14 root 2. Okay, so the hypotenuse, opposite from that 90, is going to be 14 root 2 feet, and b over here is just going to be 14 feet. Okay, so this one is easy if you can tell. So these two are going to be the same, so that I'll get 20 millimeters, and then the last one will be 20 root 2 millimeters. And then finally I have 45, 45, 90. It is x root 2. This 16 units is across from 90 degrees. So when I put 16 here, I'm setting it equal as a function. Just like we did on the other one, we divided by root 2. And just like we did on the other one, we're going to rationalize. So we get 16 root 2 over 2, which simplifies to 8 root 2. So 8 root 2 will go here, 8 root 2 will go here, and it'll be units, and it'll be units. Okay, so it sounds like some of you are a little bit shaky with SOHCAHTOA that you learned way back in geometry. And just a reminder, SOH means the sine of an angle is the opposite over the hypotenuse. Okay? The CAH is the cosine of an angle is equal to the ratio of the adjacent over the hypotenuse. And then finally, tangent or TOA is representing the tangent of the opposite leg over the adjacent leg. Okay, so one thing that you can think about that'll start differentiating all this is that both of these will have the hypotenuse, which is always opposite from where the 90-degree angle is. So sine is basically on this one going to show the sine of A. Well, I need to put myself where A is at. Capital A. Capital letters are usually for angles. Lowercase are usually for their corresponding sides. So if I put myself here, like physically, and I want to know which one is opposite, it's the one basically, like you can even imagine, like this arm is touching the hypotenuse and this arm is touching the adjacent. The opposite one is the one that you're not touching. It's way over here off in the distance. So this is opposite from where angle A is. This is adjacent from where angle A is. And this is hypotenuse from where angle A is. So if I looked at this and I wanted to see the corresponding letters, this would be opposite, which is labeled A, over hypotenuse, which is labeled C. The cosine of A now is the adjacent. The adjacent is B. The hypotenuse is C. And then finally, the opposite over the adjacent is going to be the A over B. Don't get too wrapped up in the letters because sometimes the letters will be different. Okay, so let's go ahead and do sine of D. So if I put my body right here where D is at, and I look at the sine, well, we know sine is so, the cosine is ca, and then the tangent is toa. So it's going to be the opposite over the hypotenuse, which is opposite over hypotenuse is 5 over 13. The cosine is adjacent over hypotenuse, which in this case will be the 12 over 13. And then the toe is going to be the opposite over the, so the opposite is 5, the adjacent is 12. So 5 over 12. Now let's look at Q. Now if I'm putting my body where Q is at, there's going to be some pattern here in just a bit. But again, sine is opposite, which is 12, over the hypotenuse, which is 13. And then the cosine is now right here, the 5 over 13. And then the tangent is going to be the opposite, which is 12, over 5. You should already notice that the different angles, their tangents are basically inverses of each other. You should also notice that the cosine of one angle is equal to the sine of the other, vice versa. So those are patterns that you can quick check when you're doing quizzes and whatnot. So the sine of t, again, sine is adjacent, or sorry, opposite, and it's over the hypotenuse. So this would be 2 over 15. But you would not get full credit unless it's simplified. So we will simplify it to 4/5. The cosine is the adjacent over the hypotenuse. So 9 over 15, which is going to reduce to 3/5. And then the tangent of t, that is 12 over 9. So 12 over 9, again, simplified, would give me 4/3. Now, the pattern that I just established, this should be 3/4. Let's check to make sure that that is correct. So if I put my body again at P, the tangent is opposite over adjacent. That is 9/12, and it does reduce to 3/4. The sine of P, opposite over hypotenuse. So this is opposite now, so it's 9 over 15. Again, it's going to reduce to 3/5, and you can see there's that pattern again. The sine of one is the cosine of the other. So that when I'm looking at this, it should also be equal to the 4/5, which it is in fact, after it's been reduced. Alright, so that was whenever they were labeled as T, Q, whatever letter. Now we're going to show actually angles with degrees. So there's two ways that I can do this. I can use special right triangles since they are 30, 60, and 90, or I can just see the triangle that I'm given. So the sine is opposite over hypotenuse, which is 5/10, which will reduce to 1/2. The cosine is the adjacent over the hypotenuse, which is going to reduce to √3 over 2. And the tangent at 30 is the opposite over the adjacent, which is 5 over 5√3. Now, again, you have to rationalize. Multiplying by √3 over √3 will give me that answer right there. Okay, so now over here with sine of 60, it is the opposite over the hypotenuse. So 5√3 over 10 will reduce to that. And again, that is still holding. And then 60, the cosine is adjacent over the hypotenuse, which is 5 over 10, still reducing to that 1/2, so we're still good. And then finally, the tangent of 60. So the tangent of 60, let's just start it from scratch without using the pattern. It's the opposite over the adjacent, which would be 5√3 over 5, reduced to just √3. Okay, so you notice that this is really not just the flip like the other ones have been. The way that I want you to interpret that is, so like I was saying, the way they look different right now, you don't really feel like they're the inverses. Well, think about this √3. This is √3 over 1. If I flip it, it becomes 1 over √3. Then if I rationalize it, I'm going to multiply by that form of 1 yet again, so that the bottom becomes 3 and the top is √3, which is exactly the same. So they are the same, you just have to rationalize and see even further. Alright, so looking at sine of 45, it is going to be the opposite over the hypotenuse, so it's 6 over 6√2, which simplifies to 1 over √2, which after rationalizing will simplify to √2 over 2. And then cosine, the same. Cosine is going to be exactly the same because of the fact of they both have that same side over hypotenuse. So that we could say is √2 over 2. And then the last one, opposite over hypotenuse, or sorry, opposite over adjacent, is going to be 6 over 6, which is going to in fact be 1. Things to recognize are these patterns. We will use all of these a lot. We're going to be able to find them really quickly when we start studying the unit circle here very soon. Okay, so write the trigonometric ratios for the angle B is 39. So the sine, just more practice, it's going to be the opposite over the hypotenuse. The cosine is 8 over c, and then the tangent is b over 8, which is opposite over adjacent. Okay, so number 6 says, which of these ratios could be used to find length b? So if I want to find length b, I can use this ratio here. So I would say the sine of 39 is equal to b over c, but the only part with this, as far as finding an actual answer, is the fact that I have 2 unknowns. So it can be used, but I need to know what c is. Because I don't know what c is, I cannot get an answer numerically from this, but I can from tangent. Because the tangent of 39 degrees is equal to b over an actual number 8. Then I can just multiply both sides by 8. That's just basic algebra skills. So that 8 times the tangent of 39 would equal to b. And this would give you an actual numeric answer. You can put it in your calculator, or you can just leave it like this as far as an answer. If it did say calculator and round to 3 decimal places, this is what we would do. We would go and press 8 tangent of 39. Okay, so let me go to the calculator real quick, and I'll put 8 times the tangent, so trig tangent of 39 degrees, and we would press Control Enter because we want the decimal number. Now, something that you might need to learn right now is the fact that when I'm teaching you to clear the calculator, default mode, if you were to go and press 5 settings, 2 for document settings, you're going to see this is in radian mode. You need to be in degree mode until we start doing the actual calculus stuff, which is after Christmas. It's the second semester. So you need to be in degree mode because that's what most of it is. Now you can be in degree mode and you can make it the default down here with the make default button and press OK. Or you could just leave it in radian mode the way you are doing. Let me go back to the current document that I'm on. And I can go up, press enter to copy. But instead of 39, because it's interpreting 39 radians, we can press this pi button down here and we can insert a degree symbol. So that when we do, we get a different answer. This is the degree answer because it's in degree form. Now this is still in radian mode calculator-wise, but this degree symbol right here basically trumps it and says, I want you to solve that degree mode-wise. So 6.478 will most likely be the answer. 6.478, because in this class, you're basically going to round everything to 3 decimal places if it doesn't say give me the exact answer. Okay, so now let's look at what we are doing with the next part. It says finding side lengths. So if I'm doing this trigonometric relationships, you notice that these are no longer special. They're not the 30, 60, 90. They're not the 45, 45, 90. So we need to do what we learned in geometry, and we need to set this up. We'll set it up like the following. This one's going to be, I'm given the angle, and I'm given an adjacent side, and I'm given a variable that I'm trying to solve for. So from where this angle is, this is opposite, and this is adjacent. The only thing that has opposite and adjacent is tangent. So I'll set it up as tangent of 67 degrees is equal to opposite, which is x, adjacent, which is 22. So multiply both sides by 22, we get 22 times the tangent of 67 degrees. Okay, and this is multiplication right here. It says use sine, cosine, or tangent to find and round to the nearest hundredth. So that's 2 decimal places. And I'm just going to put this into my calculator. 67 degrees. So 22 times the tangent. Whoops, I need 22. Times the tangent of 67 degrees. And again, I'm going to leave it in radian mode. A lot of you might want to do that. I would prefer to do that if I were in your shoes. And just press Control Enter for those decimal places, and it's set to 2 decimal places, so it'd be 51.83. So 51.83 is what it would be rounded to. Okay, so the next one we are looking for again is x. We put our body where the angle is at. The adjacent leg is x, so A for adjacent. The hypotenuse is 8.3, so this is not tangent. This is going to be ca, because remember, SOHCAHTOA. So the cosine of 40 degrees is equal to the adjacent over the hypotenuse. We multiply, we get 8.3 times cosine of 40, and so on and so forth. So 8.3 cosine of 40. Here we go. 8.3 times the cosine of 40 degrees. And again, I would put this instead of changing it into degree mode. You just have to remember, otherwise you're going to get the wrong answer. 6.36 is what it will be when it's rounded to the nearest tenth. To the nearest hundredth, that is, 2 decimal places. And we keep moving on. This last one, always put your body where that angle is. So opposite and hypotenuse. This is going to be sine. So the sine of 38 degrees is equal to the opposite over the hypotenuse. Now here, when the x is in the denominator, the fast way to do it is just to flip-flop those. Otherwise, you should interpret multiplying both sides by x to get rid of the denominator, and then dividing by sine of 38. So x is equal to 7.1 divided by the sine of 38. Again, we will look at this with the 2 decimal places, and we'll get control divide for a fraction. And it was 7.1 sine of 38. So 7.1 divided by, let me kick down, the sine of 38. And don't forget the degrees, again, unless you're in degree mode. And if you're in degree mode and you put the degree, it's still going to be the same answer. It doesn't undo it and change it to radian if that's what you're thinking. So 7.1, 38. My answer becomes 11.53 rounded. And that one is that. So now let's look at, these are working backwards. Now, I know in class we have already looked at the 6 trigonometric functions. It's something that I really want to stress right now. The inverse of cosine, so this is the key word right here, is 1 over cosine. This is equal to a function that we call the secant of x. If I said inverse cosine, this is equal to this notation right here, arc cosine. So what does arc cosine mean? Arc cosine means I'm trying to undo or cancel that cosine, and I'm basically working backwards from a given ratio side so that I can find the angle. On all these other ones, we had the angles given that we were given or using to find the unknowns. Here, the angle is our unknown, and it starts off as far as being written here. So that when we cancel, we get the angle is equal to whatever this is as a numeric value. So here we go. I will put my body where the angle is at. I see opposite, I see hypotenuse. Opposite hypotenuse, that's sine. So the sine of x, there's where it's different, is equal to 18 over 30. So how do I undo it? I'm going to take the arc sine, otherwise known as the inverse sine. Not inverse of sine, because that would be cosecant. I'm taking the inverse sine, or again, the arc sine. You'll hear me say arc instead of inverse because it's less confusing that way. So what you do to one side, you must do to the other. So 18 over 30, and we're going to get our answer. If we put the arc sine of 18 over 30, we'll get our angle. So let's go ahead and do that. So if I come over here and still press the trig, here's the arc sine button. Control divide will give me the 18 over 30. Okay, so when I do 18 over 30, and I press Control Enter, right now you would have that answer wrong. The reason of it being is it wants you to give it to the nearest tenth of a degree. So here, we're not putting a degree as an input. We're getting a radian angle. So you can change it to degree one of two ways. I can multiply this by pi over 180, 180 over pi, because that'll get me into that answer. So I can, let's say answer times 180 over pi. It's basically converting it over to degrees. Control Enter, and I get 38 point, let's see what we're rounding to, nearest tenth. 36.9. So 36.9 degrees. Now I could do it like that, or I could go to my calculator and say, I'm going to press 5, 2, and change this radian to degree. I'm going to make it my default. Then I'm going to press OK. Now I'm in degree mode, so that if I go to my current document and I go back up, and you see it already changed as far as the way it's displayed. If I go back here and I press the same thing, I'm not going to get that 0.643. I'm going to get, whoops, let me have to press Control Enter. When I press Control Enter, I get the 36.9. It's all about what mode are you in. Okay, so let me quickly do these other two. Opposite over adjacent, that is tangent. So the tangent of x is equal to 8 over 7. That means I'm going to take the arctangent of both sides. Those cancel, and I'm left with the x. So the arctangent of 8 over 7 is my answer. Now remember, that is finding the angle. You are going from the ratio side trying to find the angle. It already is in degree mode, so I'll press the arctangent, Control Divide, 8 over 7, because that's what we're looking for here. And then I'll do Control Enter, because I want the decimal answer. And I get 48.8. And I know it's not to scale, but it's pretty close in the regard of what it looks like. And then last but not least, adjacent over hypotenuse. That is cosine. So the cosine of x is equal to 5/11. If I do take the arc cosine, I'm going to see that these cancel. And then I can put this into my calculator. The arc cosine of 5/11. So again, the trig button, the arc cosine, the divide, as far as Control Divide, and it's going to be 5/11. So 5/11. Control Enter, because I want that decimal, and it's 62.9 rounded up would be 63.0. So x is equal to 63.0 degrees, because we have to be specific as far as what mode we were given an answer in. Let's go. Okay, so now we are going to solve each triangle and find the unknown side and angle measures, round to the nearest hundredth for the lengths and the nearest tenth for degrees. So 1 decimal place here, and then 2 decimal places over here. Okay, so here we go. N, I could solve using this. The reason of it being is I have only one unknown. So I have opposite over hypotenuse, that is the sine of 23 degrees is equal to opposite over hypotenuse, and then multiply both sides by 126, so that n is equal to 126 times the sine of 23. Something that I want to mention right now, there is not a multiplication there. There is not multiplication. It's not sine times 23. It's a composition. It's a trigonometric function. It's like log or exponential, things like that. So 126 sine of 23. I'm going to go ahead and go to my calculator. 126 times the sine of 23. Again, I'm going to put the decimal is 49.2321. And those lengths of the sides I'm rounding to the nearest hundredth. So the answer will be 49.23. So 49.23 is n. Now r will also be to 2 lengths. There's 2 ways that I can find r. I can use the Pythagorean Theorem right now. But when I use the Pythagorean Theorem, if I use this number, I might get it wrong because I'm using the rounded answer. If I want to be more exact, I'm going to use exactly the values that I was given, the more accurate one. So adjacent, hypotenuse, I can set it up as the cosine of 23 is equal to r over 126. So that r is equal to 126 times the cosine of 23. So 126 cosine of 23 times the cosine of 23 is going to give me the answer of 115.98. 115.98. Again, let's see what would happen if I use the Pythagorean theorem. That means I should get 115.98 if I did 126 squared minus 49.23 squared, and then square root that answer, and I should get 115. So 126 squared minus 49.23. Now again, this is the rounded answer, and when I get that answer, I'm going to square root that answer. So control this button right here, the negative button, will give you that answer, and then I'll control enter, and I'm 1/1000th of a point off. And that's the only thing, that's as close as I want you to get in calculus. You'll only be allowed to be 1/1000th off. If you're more than that, it will be wrong for the answer part. And now finally, the R angle. And I'm only going to do one example. From this, I think you should be able to find these two out and solve them out on your own. Big R would be just, we know this is 90. And the sum of the interior angles is 180. So if this is 90, then these other two have to add up to equal 90. So that one's easy. It's 90 minus 23 is going to be 67 degrees. And it's said to round to the nearest tenth. Well, the nearest tenth is 0.0, so that doesn't matter. But you would have that as an answer. Okay? And then you would do the other one similarly. Now we move on to law of sines. And I'm actually going to save this for the next video, so I will stop right there.